video, I would like to show a little bit about what the function y equals, or f of x equals 1 over x looks like. The function that we're going to define as the parent function for this family of graphs known as reciprocal functions. So here I've set up the function f of x equals 1 over x, and I have several test values that I want to go ahead and plug in, and we'll see what that gives us when we plot those points. So here we have f of 0. If I plug 0 in for x, I would have 1 over 0, which would be undefined, with a 0 in the denominator. When I plug in 1 for the x, 1 over 1 would be 1, so the point 1, 1 is on the graph. When I plug in 2 for x, I would have 1/2, so the point 2, 1/2 is on the graph. When I plug in 3 for x, I would get 1/3, so the point 3, 1/3 would be on the graph of this function. Plugging in 5, I would get 1/5, so 5, 1/5 would be another point. Plugging in, let's jump a little bit there, I don't need to do all of those. Plugging in 10, I would get 1/10, so the point 10, 1/10 would be on the graph of this function. Doing some negatives so we can create the other branch of this graph. We would have -1, -1/2, -1/3, -1/5, and -1/10. So each creating another ordered pair for the points on this graph. So I'd have -1, -1, -2, -1/2, -3, -1/3, -5, -1/5, and -10, -1/10. Let's go ahead and graph those points and see if we can start to see the shape of this graph take place. I don't think we're going to quite see everything that we need to yet, so I'm going to go back and add some more to this afterwards, but let's plot these ones for now and see where we're at so far. Let's go ahead and plot those points that we just found so we can get an idea for what this graph looks like. We plugged in 1 and got 1. We plugged in 2 and got 1/2. We plugged in 3 and got 1/3. Next one we plugged in was 5, and I got 1/5. Then I jumped a bit more and plugged in 10 and got 1/10. We plugged in 0, it was undefined. We plugged in the negatives as well. So when I plugged in -1, I got -1. When I plugged in -2, I got -1/2. When I plugged in -3, I got -1/3. Over to -5 and got -1/5. And then jumped to -10. And got -1/10. Now, I can sort of start to see the branches of the graph taking shape, but I don't really think that it's quite clear what it's doing here as it approaches the y-axis. Whoa, didn't want to do that. Oops, there we go. As it approaches the y-axis, you can see as it's coming down, it appears to be getting closer and closer to the x-axis. So we kind of see that behavior at approaching that horizontal asymptote of y equals 0. There is a vertical asymptote of x equals 0 here where this is undefined, but perhaps we should add a few more points to the graph so that we can see that. Let's go back to our function and plug in a couple more values for x to get a better picture of what this graph truly looks like. So I'm going to plug in some fractions here between 0 and 1 so we can fill in that part of the graph a little bit more accurately. I've selected 1/2, 1/3, 1/5, and 1/8 just to give us a decent representation in that window, as well as the negatives of those so we can get the other branch of the graph. So when I plug in 1/2, I would have 1 divided by 1/2, and just remember that dividing by a fraction is the same thing as multiplying by its reciprocal. The reciprocal of 1/2 would be 2, so 1 times 2 would be 2. Plugging in 1/3, again, dividing by 1/3 is the same thing as multiplying by its reciprocal of 3. 1 times 3 is 3, and so on. That would be 5, and that would be 8. Same thing over here for the negatives. Plugging in -1/2, the reciprocal of -1/2 would be -2. So instead of dividing by -1/2, the multiplying by -2 would be equivalent. So 1 times -2 is -2, and so on. This would be -3, -5, and -8. Again, I'm just plugging those in, and then instead of dividing by the fraction, I'm multiplying by the reciprocal. That is equivalent. So I have 1/2, 2, 1/3, 3, 1/5, 5, 1/8, 8, negative 1/2, negative 2, negative 1/3, negative 3, negative 1/5, negative 5, and negative 1/8, negative 8 to go ahead and add to my graph. So let's go ahead and do that now, and then I think we'll have a better picture of what this graph looks like, and we'll include the asymptote line. So here I am back at the graph that we were at before. I'm going to go ahead and add these additional points to this. We have plugged in 1/2, and we got 2. We plugged in 1/3 and got 3. We plugged in 1/5 and got 5. And then we plugged in 1/8 and got 8. So we can see that branch of that graph tracing in a little, filling in a little bit better as it, and see it approaching that vertical asymptote line. Let's put the negatives in so we can do the same thing. We put in negative 1/2 and got negative 2. We put in negative 1/3 and got negative 3. We put in negative 1/5 and got negative 5. And finally, we put in negative 1/8 as an input value, which produced negative 8 as an output value. I'll go ahead and turn all those to blue to match the rest of them. Go ahead and throw my asymptote lines in there. X equals 0 is my vertical asymptote line, and Y equals 0 is my horizontal asymptote line. Go ahead and make those asymptote lines red and dashed to keep consistent with other examples that I've done. So you can see the function approaching the vertical asymptote as it goes towards 0 from either side. It approaches positive infinity from the right side and negative infinity from the left side. And you can see as we go towards positive infinity in the x direction, it is approaching 0, and the same thing is happening as we approach negative infinity in the x direction. It is also approaching 0. If I wanted to go ahead and actually graph the function itself, y equals 1 over x, you can see it passing through all of those points that I have plotted. And this represents our parent function for our family of graphs. We can certainly do all sorts of things to it. If you look, if I change the 1 to a 2, we already graphed that function in a previous example, but that should be a vertical stretch. You should see the graph appear to be twice as high. So look at all those y coordinates. Specifically, this one right here that it was at 1 is now at 2. This one that was at 1/2 is now at 1. This one that was at 1/3 is now at 2/3, and so on. I put something at the end like +1. +1, you can see the graph just move up. The asymptote line moved up with it. And if I were to put something down here in the denominator of the fraction like -1, you can see that would move it to the right. Just like subtracting 1 on the interior of any of the functions we've looked at, like that moved it right 1 unit. So there's some connections to previous content, but this is your parent function, and then we're going to look at some transformations and how the transformations affect certain characteristics of the graph as we go forward.